Welcome to homework.
In part A, we are going to talk about what does the equation y equals x squared represent as a curve in R2 in the plane. In part B, what does it represent as a surface in R3? And in part C, we discuss what does the equation z equals y squared represent. So y equals x squared, we all know that this is a parabola in 2 dimensions. That is, if we join points x with its square, we get this type of curve, which increases without any bound to the right and to the left. At 0, it is 0. At 1, it is 1. At -1 is 1. At 2 is 4. Like that. So it's a parabola. But what happens if we consider this same equation in the space in 3 dimensions? Well, the equation is the same. It means that the third variable z appears with a 0 coefficient, so z can be any value and the equation is fulfilled. It means that drawing 3 dimensions, if we have here x-axis, y-axis, and z-axis, then in the xy axis, let's say we have the negative part of x here and the negative part of y here, the negative part of z down here. And on the xy axis, we have the same curve, let's say this parabola here, drawn on the plane xy, but then as c is the same, is any value, then what we will have is that parabola can be drawn at any value of c, and that will form the surface. That is, the surface is what we call a cylinder. So we will have this. That is, if we look from certain inclination here, we can see this. That's the figure with infinity here and here. That is, this surface doesn't end on above and below. It goes upward all the time and downward. And at any height, that is, if we put a plane parallel to xy at any value of c, we get the same parabola. So that's what we call parabolic cylinder. That is, we have the shape of the parabola on the plane xy, and that is extruded up and down to form a surface, which then is this shape here. If we look at different angles, it is clear that the cylinder in this case goes up. That is, if we make some traces, we see that. We see the parabola is replicated at any height. So that's the surface that is formed. And when we talk about z equals y squared, it happens the same. That is, z equals y squared will be a parabola on R2. But in this case, it is drawn in plane zy. That is, if this is a plane cy, then the parabola is this. Just the same as this. So that the only difference that here we have the independent variable is the horizontal x, and the vertical axis is the dependent variable y. So here the independent variable is y and the dependent variable is z. But the shape is exactly the same, and we have exactly the same type of curve, that is a parabola. But in the space, now if we look x, y, and z, and we have the parabola at cy, that is, now this is, let's say, and we draw a parabola at the plane cy, that is something like this. And now we got to put this parabola at any value of x, because now x is a variable that doesn't appear, so x can be any value, and we'll have this shape here. That is, we put this parabola everywhere along the x-axis, and we get this cylinder. Again, it's a parabolic cylinder, but the shape goes along the x-axis. That is, we have this, without this, sorry. We have this shape here, and in this case it goes along the z-axis.